Continuing on, we're going to look at some important bullet points to be familiar with for Chapter 8, and that dealt with hypothesis testing. So first off, you need to know how to write the null and alternative hypotheses for a hypothesis test if you're given a variety of scenarios. So recall, the null is the HO. It always has the form P is equal to some value. The alternative, the HA, is that P is either greater than, less than, or not equal to that same value from the null. You'll know which symbol to use based off of the wording you see given in the problem. This is the first step to a hypothesis test. The second step is to check the central limit theorem, which we discussed in the Chapter 7 review component. The third step is to find your z-score, your z-test statistic, your p-value, and your sample proportion for our one proportion hypothesis test. Just a reminder of how to do that on your calculator. You go to Stat, Tests, and it's number 5, 1 prop z test. PO is your decimal that you set in HO. X is your actual number of successes given in the problem. N is your sample size, and you select your symbol based off of your alternative symbol. When you hit calculate, you'll see your z-test statistic, your z-score at the very top. Then you'll see your p-value, and then you'll see your sample proportion or your p-hat. Now, for the formal definition of a p-value, you can find that in your Chapter 8 notes. A p-value is the probability of observing a sample proportion as extreme or more extreme given the conditions of your hypothesis test. It's a probability, and it's the probability of observing sample proportion as extreme or more extreme given the conditions of your hypothesis test. We should be using the normal curve, as we're checking the central limit theorem. On that normal curve, our P is in the middle, and then our p-hat would be somewhere to the right or to the left, depending if it's greater than or less than. Now, moving to the next bullet point, we can estimate the size of a p-value based off of a z-test statistic. Pretty much, the farther the z-test statistic is from 0, the smaller the p-value. Z-test statistics or z-scores are based off of the standard normal curve. So let's say I have two z-scores. I've got one z-score of 1.47. The other z-score is negative 2.5. So 1.47 would be somewhere up here above the 0. Negative 2.5 would be down here below the 0, and it's a little bit farther to the left because it's farther from 0. The associated p-values or probabilities are in the tails. The z-score associated with 1.47, the p-value associated with 1.47 would be this area. This is its p-value. For 2.5, it would be this smaller area. So we could see negative 2.5 would have the smaller p-value based off of this illustration. The farther the z-score is from 0, it doesn't matter if it's above it or below it. Being positive or negative has no effect. The smaller the p-value. The farther the z-test statistic is from 0, the smaller the p-value. Now, to know whether or not a p-value is surprising, you want to compare it to your level of significance. If your p-value is less than alpha, you reject HO, your baseline from old data. And this is surprising. Your sample is showing something new that you haven't seen before. You're rejecting that old baseline, that old information that you have from previous studies, so you have a surprising result. So if the p-value is less than your alpha, you reject HO. You could also say that the data are statistically significant to support HA, your alternative. On the other hand, if your p-value is greater than your alpha, you do not reject HO or fail to reject HO. The result is not surprising. And you can say the data are not statistically significant to support the idea of HA. That's how you use your p-value to make your decision and conclusion about the alternative hypotheses. Final 2 bullet points: how to conduct a full one proportion z-test statistic hypothesis test on your calculator, as well as the 2 proportion. Both of them are under stats tests. The 1 proportion, when you have one group, one sample, is number 5. Again, PO is your value that you have in HO. X is your actual number of given successes in the problem. N is your sample size, and you select your symbol based off of your alternative. For the 2 proportion, it's stat test, and it's number 6, the 2-prop z-test. X1 is the given successes for the first sample. N1 is the sample size of the first sample. X2 is the given successes for the second sample. And N2 is the sample size for the second sample. And then once again, you select your symbol based off of the alternative. That will get you everything you need to begin to make your decision and conclusion about the null and alternative hypotheses.